मनी यूट्यूब पे आपको ब्लैक कैम ने
Online में बाल ना आए
Greetings and welcome to Nexus
अरे
Sky, a groundbreaking webinar
पता
presented
उड़ेगा
by the
मत तेरे
Satellite and
दादी
IT division of SEDS OUSL. In the next 2 minutes, join us on an exploration into the extraordinary convergence of artificial intelligence and space technology.
इनका
Our
क्या
mission
है
is to harness the power of artificial intelligence to propel the frontiers of space technology, unlocking new realms of knowledge and discovery. Artificial intelligence plays a crucial role in space exploration, revolutionizing various aspects of the industry. AI technologies enhance spacecraft autonomy, enabling them to make real-time decisions, navigate through complex environments, and adapt to unforeseen challenges. Machine learning algorithms analyze vast amounts of data collected from telescopes, satellites, and rovers, helping scientists identify celestial objects. Discover new phenomena and understand the universe's mysteries. Additionally, AI contributes to mission planning, optimizing trajectories, and improving communication between Earth and spacecrafts. With AI, space agencies can streamline operations, reduce human intervention, and uncover new possibilities for exploration, making it an indispensable tool for advancing our understanding of the cosmos.
Okay, everyone. It is now time for the highlight of our event, introducing you to an innovative educator, an empowering researcher, and a strategic and inspirational leader, a keynote address by none other than Dr. Prashant, the Department of Engineering at the of Peer Avenue, consultant at Lanka Education and Research Network, and the board member of Asia Pacific Advanced Network. Professor Roshan was a core group member for higher education at the Presidential Task for Education set up in 2020. He's a member of UGC's Standing Committee on the Development of IT Infrastructure and Online Education and member of UGC appointed committee to develop the concept of virtual and hybrid university. His specialized in the field of artificial intelligence and his contribution to space technology are truly commendable. So let's welcome Professor to share these insights with us.
Thank you very much. Let me share my screen. Right. Good evening, everyone. Thank you. Thank you for having me to SEDS Open University of Sri Lanka for organizing this session for me to share a little on AI beyond Earth. Okay. skip that. So today we are going to talk about artificial intelligence, not just about artificial intelligence, but artificial intelligence, how it overlaps with space exploration or space in general. The topic of interest to you all is, I believe, more on space exploration than AI. However, here we are going to look at the intersection of the two. So how I'll go about it is I'll start by talking about AI and where else AI is used. The other places are the situations where AI helps human life and obviously other lives. And then I'll go into the major topic, which is space exploration and AI, how AI can be used in space-related activities, exploration-related activities. Next, I'll take a few moments to explain the type of projects we are doing at University of Peradeniya, from where I'm coming. Before we closing, I'll also talk about a few concerns that we have related to artificial intelligence, particularly in the latest era of AI, the concerns that are there, ethical and otherwise, and the regulation that are set up in general, and also specifically related to space exploration, AI-related regulations related to space exploration, and then I'll conclude. So that's the plan. The session is expected to last for about a couple of hours. We'll try and squeeze it in as much as possible. So we'll start with what is artificial intelligence. AI is a reasonably old term in the context of technology, particularly technology with computers are involved. So just to give you a very brief and very high level perspective of what artificial intelligence is, AI is, we can like briefly say it's development of systems or machines, computers, which can perform tasks like us. So, or particularly tasks that requires human intelligence. So if a machine can do, or a system can do something that requires usually human intelligence, then we call it artificial intelligence. So with over time, AI has dived into various different sub-branches. One of the major ones that took over in the last, say, about 20 years is machine learning. So where we want the machines to learn like how human or any other living creature learns, or particularly human learns, because we are interested in intelligence of human-like. So how we learn, can machine learn something similar or some similar way? So that is the idea behind machine learning. So can we make machines to learn like us? How do we learn? We learn by observing, we learn by hearing, we learn by seeing, and these senses that we use. And then we take these and reflect on them, various other things that we do inside our brain, and then we learn. So can machines do something similar using sensors, and particularly using data, the data that is coming out of the sensors, is what the interest of machine learning is. And with machine learning, there are other areas like artificial neural networks, which basically is made similar to how human brain works, is built, which is known as the ANN, or the artificial neural network. And with that, we also started talking about what is known as the deep neural network. With that synonym, we also have deep learning with deep neural network. So we are again talking about how machines can learn, like how we learn. In the recent times, we got into this sub-specialization or this branch, which is known as generative artificial intelligence, or in short, Gen AI, which with all this deep neural network and a vast amount of data that is generated, that is produced, the latest development is related to how this data and also the deep neural networks can be used to make what is known as generative artificial intelligence. What's special, what's specific about Gen AI is that now or in the past, with just to compare, in the past, what AI or the machine learning algorithms models were doing is it trains from some known data, and when you see an unknown one, it matches the unknown information with its previous known information and produces something out from the known to the unknown. Now the generative AI takes a step further and tries to come up with new data based on what it knows already. So it is done in multiple ways. One, by using what is known as large language models, and another one is known as the generative adversarial networks, or GANs in short. So that's like a little background and also some theory on what AI is and how we are at a junction now with this big hype with generative AI, with all these different tools that can generate a new knowledge. So generative AI, like I said, it can do text. So you can give what is known as a text prompt, and it can generate by taking the text prompt, going through a model, it can generate a new text output. Not only text, with generative AI, the adversarial networks can also generate other things. So it can take a few different images, it knows those, and we can prompt it by knowing the images, can it generate a new image with new knowledge, like the knowledge that I generate. So that is again is possible, and I believe all of you have used a lot of different tools that can do all these different things in the recent times, particularly within the last year or so. So let's start with a little quiz or a poll. It looks like we don't have a poll ready in Zoom, and therefore let me give you another platform for your poll. So either you can, I believe you still can see the screen. Either you can scan this QR code or go to gosocrative.com and enter the room SEDS. I'll just copy paste this to the chat so all of you get access. So you can go to that link and enter the room name, or you can just scan the QR code here. And let me now put the question back. The question is there in the poll itself. So when you are here, let me put the question back. So it's just to get your perspective on what we discussed up to now. Right, I assume we have given enough time, so let's check the answers. In fact, like most of you are thinking, deep learning and generative AI is the most transformative in the next decade. I think like most of us, including myself, are also believing it's going to be the case. The reason being, if you take AI as it is, it was a transformative technology. AI, like I said, is reasonably old. The idea and was from, as you know, it started way back, now about 50 years. The concept of from the time we figured out, okay, we can use machines to do things like us, a little repetitive task and so on, when programming was invented and so on, all those days, since then, we are thinking about making machines like us. But, and also over time, we have done reasonable amount of work to make machines to do things like human or repetitive tasks. But Gen AI, generative AI, that can generate new things and is changing the landscape of technology in a big way, because it's not only enabling us to do repetitive tasks, but also it's helping us coming up with new ideas, new knowledge, new ways of doing things based on the existing ways, like how we learn, right? How humans learn and come up with new ideas. So it also make AI in the current form. It also let us or let machines to make decisions instead of we human telling machines to make decisions. So such a situation is more transformative, at the same time more concerning. Right? So therefore, we also have to look at how it can be properly within code done. Right? So that's part of the discussion I'll have today as well. So, but then, yes, I also agree that Gen AI and deep learning is the one that's, like most of you are thinking, is going to be the most transformative one. So let's move on to the second. Let me just so we go to the next one. Yeah, right. So the next topic I wanted to touch upon is how AI is used in a lot of different places before we dive into the topic of your all interest, right? So that is everyday life, everywhere else. I just took a picture from a website, impact of AI on everyday life. The picture just highlights the different aspects of how AI can be used. This is not a comprehensive picture to highlight everything that we can do with AI, but it gives you a glimpse of the different type of things we can do. Starting from let's say you are writing emails and sending emails. You know, like with time, a lot of emails are generated by people of our interest, those who send email to us. And at the same time, people use this medium, emails, to send emails of not of our interest, email that we don't like to receive. So those emails are called spam. And there are now AI technology that can understand and identify these emails and stop them coming to us. That technology is, and also it can send reply emails to such emails if it's required. For example, if there are situations where such emails can be stopped by sending a reply, I don't want to receive any more, AI systems can do it. Right. So just to take some other example, if you are going to search using search engine like Google, the search engines are no longer just using the standard keyword-based techniques, but it also now use AI-based techniques. So some intelligence in the way how you search, how you find answers to what you are looking for. Various other places, for instance, detecting when you are doing transactions in a bank online, whether there is the requests that are going from a customer in a bank, whether it is reliable, whether it looks like the customer's request or it's coming from somebody else, some adversary. Right? So that sort of things. And deciding which videos in YouTube someone would want to watch and which one they don't want to watch. Right? Which ones are more appropriate, which ones are more interesting, which ones are more useful. That sort of situation where AI is used. We can keep on going. Then there are places like where if you want to do things like a parcel delivery company, if you want to deliver goods to a lot of people in around the world or within a country, within a region, within places, how do we optimally route based on various other information, things like the routes, things like where the parcels are supposed to be delivered, all sort of different things. And obviously other places where there is speech recognition used. In fact, as we speak, the Zoom meeting we are having right now uses AI summary, which basically listening to what I'm saying and then going to give me a summary of all what I discussed here. So even this Zoom meeting has another feature called AI companion that can also listen to the discussion that is happening in the room or in the Zoom meeting. So they are all different places, situations where AI is used in everyday life now. So we'll take So this video is a video prepared by a company like Coca-Cola for the advertising. But usually when they want to create a video like this, these videos are not new. So these sort of videos are created for a very long time for advertising. However, this particular video is special because it was created using generative AI, meaning we just ask AI to with some prompts, with some information given in text or voice, and it generated all this without human intervention in terms of putting things together, putting videos together, images together, animations together, all that are done by AI. So that redefines the way how we can do things. So like we all agree, even when I asked the question earlier. I'll skip that and move on to how we can use AI in space. That is the most core topic for today. So space exploration and AI, I'm going to take it under a few subtopics before we go there. Just to understand how it is different, the context of space and usage of AI is different to the context of Earth and where we are right now and the use of AI. So the interesting part is that in here, we are also here, human. And remember, AI is supposed to sort of mimic human intelligence. So the interesting thing is in space, we don't have a lot of us there. Yes, we have some devices that we can communicate through. And there are a few of us who are there in various places, either in the space stations or and so on, but not many are there. So space is a place where it make a lot of sense, at least for now, have some intelligence, which is maybe subpar to us, not as good as our intelligence, but some intelligence that can help us do things that we want to do there. So it makes a lot of sense to use AI in space. And therefore, it's not very new. The space exploration and various other aspects of space have used AI, or those who are working on those have used AI for a reasonable amount of time now, at least for the last 15 years or so. And with generative AI, things are taking shape even better. So therefore, like let me just take a few moments to understand how we can use AI in space under various subtopics. So I'm going to cover topics related to data analysis. I'm going to cover topics related to AI robotics. So data analysis related to AI, space exploration, robotics, safety management, both safety of humans, safety of the equipment that is in there, and space navigation, planetary navigation, and then communication and system control. In fact, most of these topics were mentioned earlier by the organizers' video, the video that highlighted the promo that you we played at the beginning, highlighting the same things. So let's start with the very first one, data analysis. So here is an example. Sorry, where AI can be used for analyzing a lot of data. So there is a problem in general when you want to do space exploration. Let's say we are going to use a telescope, the Hubble telescope, for example, right? And we want to explore or identify interesting areas in the space and do some analysis. So maybe what we'll do, maybe we'll take some photos, right? Can all these photos be sent to the place where, or to the people who are interested to analyze or to look at it and to find things? So usually in the past, what was done is, yes, there are a lot of ways that are used to send this data. They are compressed, they are made smaller, and they are transmitted in various forms and ways. But now that if you have some intelligence that can sort of complement us, and can we put this intelligence there in these telescopes, for instance, example, and use the intelligence to identify things like objects of interest, or filter out noise that is coming out of that is there in the capturing of those images, for instance, right? And then we can decide, this intelligence can decide which pictures make sense to send to the observation of human, or use it in some form or ways. So meaning we can use AI, or in fact, like AI is used in identifying objects, filtering them, particularly filtering because we are talking about analyzing data within this lot of data, different forms and ways. It's not possible for humans. One, it's not possible to send technologically all the data across because it's very costly to transfer data. Even it's very costly to transfer data within Earth itself, and transferring it from space to Earth is even obviously more costly, and takes a lot of time because transferring data rates, trade data takes longer time. So therefore, we can use AI to identify what is more interesting and filter out, remove things that are not of interest, and send only the relevant images, making things easier and faster and efficient. Obviously, there are also negatives in it, meaning if the AI, what if the AI miss it? What if the AI miss that we want, as human want to see, right? So that's possible because AI is not perfect. So are human. And therefore, there are challenges. However, it's an opportunity that we are looking at. So more on the data analysis. So in fact, like there are a lot of recent news items from NASA on these sort of aspects, how AI is used in observations, identifying the right information out of a vast amount of data that is coming out as high resolution images and so on. So here is the second one from another telescope. So that's just a little on data analysis. So what we saw is not just that we can use AI to identify what is good, what is useful, what the exploration part of it. However, at the same time, we also can use AI to filter the right data so that we don't have to transfer everything that is captured, which is very costly and time consuming, transferring everything that we capture. So identifying what has to be transferred without, if not, we had to put somebody in all these telescopes to do that work there itself when you're capturing. Now we put an AI there that does that work and send us only those that we think are of or the AI think that are of interest. So which also brings us to the question, we are going to rely on AI to make the decision which ones are more of interest to the scientists we have on Earth. So that's data analysis. The next one will take AI robotics. So AI robotics is actually robotics in space is a very old topic. Why so is because for obvious reasons. The challenges we have in taking human and keeping them there in space. We have been looking at building robots, even sending them for a very long time. Even if you are sending human, we can't send them just as it is, and we had to send them with some support. And robots were in the horizon for a very long time, right? So, but we in the 60s and 70s, so here we can see a timeline coming from. I just took this picture from somewhere in a source. So starting from 1960 up to now, what's going on one side is the timeline. On the other side, level of autonomy on board the robot. So how autonomous the robot can be. Now that with generative AI and the new ways of making robots are changing, and therefore we believe we can do a lot more, almost like human-like behavior in robots. So we can start at the very beginning in 60s, 70s, even now in the recent times, we still have teleoperated robots that we can control from here, from Earth. And then we have automatic operations, so certain operations which are pre-programmed that can be done, semi-autonomous. So operation that can be partly done using what you call some pre-program, but at the same time, some of the things semi-autonomous, meaning some of the things can be done will be done by the robot on its own. So it decides, okay, what to do next or what to do in a particular situation when the situation arises, which is not pre-programmed as it is. So it become autonomous semi, and then you also have the fully autonomous operations. So these are different type of operations that we are classified. And over time, we can see we are going more towards the fully autonomous operations with what are known as the robotic explorers or assistants. In the past, we had what is known as robot agents, where we had mostly either teleoperations or automatic operation, where we pre-program what exactly the robots are supposed to do. So this is just to give the overall landscape in the AI robotics in the space exploration domain. Here is a small video clip on whether AI can help, or sorry, the robots can help, robots with AI in it in space.
Yeah, robots have been helping humans in space for a long time. We've sent rovers to Mars, spacecraft to orbit other planets. Robots have even been helping astronauts on the International Space Station. One of the really cool things about robots is they can help humans do repetitive or even dangerous tasks. With Artemis, NASA is working to build a sustainable human presence on the moon, and robots will be an important part of that. They will help build new structures, perform inspections, gather data from previously unexplored areas, and perform science experiments to help us understand the environment. And now we're making even more advanced, intelligent, and agile robots. At NASA's Jet Propulsion Laboratory, we're working on a project called CADRE, short for Cooperative Autonomous Distributed Robotic Exploration, to demonstrate a new technology of cooperative multi-agent autonomy. Cadre is a network of shoebox-sized mobile robots that will coordinate amongst each other to accomplish a goal, such as exploring or mapping an area, without a human controller in the loop. This technology will change the way we think about missions in the future and unlock immense opportunities. We could explore areas that are not easily accessible for humans, like lava tubes or icy caves or subsurface oceans in search of water and other minerals. And it would be okay even if a robot doesn't make it back out, because it would have shared its data with the rest of the team. So the robots help humans in space? Yes. And at NASA, we're building a whole new fleet of robots that are going to help humans explore Moon, Mars, and beyond.
Right. So like it was said, robots are going to help humans in space exploration, including our mission to Mars and Moon and other planets and so on. Here is another poll. Let's see, because I keep on talking, let's take a short break and answer this question. So the question is, which of the following is an example of an AI robot, robotic assistant that was used by astronauts? Whether you know. 1 A is Simon, B Robonaut, C is TAS, D is iRobot. And let me open up the poll again. Again, you can go to the same place like you went last time. The link is in the chat. Those who came late, joined late, I can just copy paste the chat one more time. Or you can just scan the QR code there on the screen. So let me go back to the question. I'll give a couple of more seconds before we move on. So majority of you have actually voted for A. And the second highest is C. And then B. And a few for D. So majority of you have voted for A. In fact, like there's no single answer to this question. Let's see what the answers are. Thank you for voting. So first one is, we're talking about robots in space. So here is one, which is the AI assistant, Simon, or Crew Interactive Mobile Companion, command for short. It is a robot that is there in the International Space Station for a while. Actually, it's there since, as you can see, 2018. Right. So for a while, so what it can do, actually, it can fly. So I mean, okay, it's a space station. So yeah, it's flying, and then it can talk. It can look at. It has the video camera, so it can speak here, interact with us, interact with obviously the astronauts who are there, and so on. So it can do all that. And this was built by the German space agency with the help of Airbus and IBM. Airbus, as you know, is what Airbus is. So those who are building even the rockets and planes, obviously. And IBM is a computer company. And then the space agency of German. So they build this Simon, and it can do all these different things. And it can do it all of these in natural language. So you don't have to program it. I mean, be in the sense, those who are using it don't have to program it. They can just use it. It's there for about 6 years. Then we also have a Robonaut. In fact, like that is another other answers I gave. Very few of you picked it. So it's there for a even longer time. It was built by NASA. And what it can do, it's as you can see, it's more like a humanoid, human-like robot. It is used for the usual human type, how humanoid robots are expected to be used. Right, so that is another concept we have to think about. So when you're thinking about robots in the past, we were mostly thinking of robots and particularly AI and robots. We used to think about them as similar to humans, because AI is supposed to replace human intelligence, and therefore the robots that are coming out had to look like us. That was the idea. So here is one which is like us, but if I'm right, this has legs and also it has wheels. So it can walk, also move faster with the wheels. So it can do a number of things. So it's there for a reasonable amount of time now. Recognize objects and faces. It uses what is known as machine vision or computer vision. It looks through the cameras and uses vision to understand the objects. And there's a lot of machine vision related research work that are done to understand what these things are, or to improve the performance of these robots or humanoids. So it can also talk. It can it has because it's like human, it can do some activities like how human does. Not as flexible as human, but it can do. And also it has some adaptive algorithms, so it can learn or self-learn using what it knows earlier. So now with all these large language models and GANs, it's possible to improve such robots even to behave more human-like. So those are a couple of examples in the robotics area. And In fact, there were questions about, I saw like the pre-collected questions on robotics, and this I hope answers those. And the next area I'm going to cover is space related safety management. So space exploration, but sort of safety management that can be done using AI and yeah, AI and beyond, right? So the current setup. In fact, like when you think about AI and its application, one of the application that is very critical and useful, and also one application that is very concerning is its application to self-diagnose and repair, right? So you see, like human, one of the things that we as human are good at doing is repairing ourselves, our doctors who are helping us doing it, learn and do. But when it comes to robots or AI robots, they are, human has to repair them. Humans has to diagnose what's wrong with them, right? So it has to be done by human. So there, it's a conceptual mind shift or mind change or shift when if robots can do, AI can self identify problems and repair themselves, right? So that's an interesting area. And it also applies in what do you call, in space. So, but now we'll start the safety management with an example in satellite operation, particularly satellite operations and collision avoidance. So in fact, as you know now, the space, our closer one to Earth is occupied by a large number of satellites of various agencies. So all of these are, there's high chance that they all can collide with each other. So how are they avoided these days is by again using AI algorithms. For doing what? For identifying another satellite that is coming closer and then readjusting, obviously communicating between and readjusting the paths and the speed. So you can control, obviously it's like how human drive either planes or even on road, how we drive vehicles. Can AI, obviously in the satellites, we don't have human to do it. So can AI sit there and do this for us? The operations of the satellites and collision avoidance. It's done by AI actually. And it's not just in the space like in satellites, but also in explorations like Mars exploration, where the Mars rovers, the Mars exploration rover and also Curiosity, they had this autonomous navigation. They used AI to do that. So what it does is it can sense the environment, what's going on around, and then decide how it can safely navigate. So it's also robotics at the same time. It's also safety management. So I'm talking about the AI part that does the safety management here, not just the robot itself. That's the difference. So here it does safety management. The AI is doing the safety management. So AI is not only doing the safety management of robots, but also it does safety management of human, obviously here on Earth, but also in space. So here is an example from space where AI can monitor the health of astronauts for AI, for various monitoring things like what is happening here on Earth, but we had to be more careful there because of the limited environmental condition that these astronauts are in, including other issues like the cosmic radiations and so on. So there's higher risk, and therefore AI algorithms, so obviously sensors are sensing their vitals, and AI algorithms are detecting or managing the safety and alarming if there are problems. So there is more in terms of, this is what I earlier talked about, in terms of safety management. There is a whole area of research in what is known as predictive maintenance. Predictive maintenance. The idea is, like whether we can predict failures of systems. It is done on Earth And also it's obviously more important in space. So what it does is AI algorithms get sensor data of machines, of engines, of even themselves, the AI robots themselves, look at those data to predict when and where they are going to fail, and use AI to do that. And with that predictive propositions, it's possible for them to self-repair, meaning maybe they can just change a part on their own, or they can seek for assistance from human. Right, so that this becomes a very interesting and a shift in the way how robotics work and machines work. Predictive maintenance can be a way of self-sustaining these machines without or with little human intervention. So that's another area where the AI is used in the space. One more questions. So which rocket is known for being reusable and has successfully launched numerous payloads into space? Saturn V are the 4 answers. You can give your answer. Let me open up the same poll again. Yeah, like it was said, if you have any questions, please feel free to stop me and ask. I'm happy to answer them. You don't have to wait till the end. Let me turn on the... Yeah, it's on now, and we have to go to the same link. The link is in the chat. Thank you for all engaging. I see most of you, actually almost all of you know the answer. It was a very popular discussion in the recent times. So things like, yeah, so reusable rockets are one of the major way of reducing the cost for space exploration. So thank you all for answering. Actually, the answer is on the next slide. So it's Falcon 9, which is a rocket from SpaceX. I assume all of you know about SpaceX being interested in this topic. And the idea of this robot, in fact, like this rocket has been reused several times by now. So therefore, it's the whole idea is that the reusability brings down the cost. But why it is connected to the topic of AI, right? So particularly why it is connected to the topic of AI is how Falcon 9 decides where to land is actually done by a computer vision algorithm. It is done by AI. Obviously, there's no people to do it there. And AI is, and even if there are people, AI does a better job of doing this computer vision algorithm by analyzing a lot of points, data points, and doing it. So that's how the AI is in the context there. So here is a small video clips on the topic.
Successfully launched their 8th mission of the year with the launch of Starlink 638.
Power and liftoff. Go Falcon and go Starlink.
The booster which launched this mission, B-1062, then landed successfully for the 18th time on the drone ship A short full of gravitors.
Stage 1 landing confirmed.
Also on Monday, SpaceX successfully launched their 9th mission of the year with the launch of Starlink 712.
1. Ignition. And liftoff of Falcon 9. Go Starlink. Go SpaceX.
The booster which launched this mission, B-1075, then landed successfully for the 9th time on the drone ship Of Course I Still Love You.
Stage 1 landing confirmed.
Then on Tuesday, SpaceX successfully launched their 10th mission of the year with the launch of NG-20.
1. Ignition. Engine full power. And liftoff. Go SpaceX. Go Falcon.
The booster which launched this mission, B-1077, then landed successfully for the 10th time on the landing pad at Landing Zone 1.
Back down on land.
Stage 2 FTS has saved. Stage 1 landing leg deploy.
Successfully launched their 8th mission.
Right, so that was about SpaceX and how Falcon 9 is taking a lot of satellites actually also to the space. So here is another question for the movie lovers. Let me bring up the poll to answer it. Yeah, so you can use the same link again to give an answer. Those who joined recently can use go to your chat, and the link for answering the poll is there. It looks like most of you are thinking it should be a movie related with a title which has some space element in it. Right, so thank you for answering. In fact, like, okay, it's not B. So here is a post from Elon Musk from SpaceX. So actually the movie that was filmed, or part of it, a little of it is filmed in SpaceX is Iron Man 2. Right, so let's move on to the next topic, which is the space navigation. Finish this before continuing. Okay, there's also a question. So maybe I'll take the question before I go into the next topic because it's make it more interactive. The question is how does AI help make space missions work better? Can AI help us learn more about space by looking at pictures from space telescopes? Yes, in fact, like I was highlighting a little in the topic of data analysis. In the data analysis, what we discussed is can AI look at the photos that are coming from the telescopes, the space telescopes, obviously, and help us narrow down, because space telescope, like how space exploration works, right? So when you use telescopes, either you stream those photos to Earth, and there are people who are sitting here and looking at what's going on in those pictures or in those photos, or the transmission, which is basically photos, which is a lot of work in the sense of a lot of people observing them. And at the same time, it's also a lot of work in the sense of technology that transfers all the data from those telescopes to Earth, which is very, very, very expensive and slow. So one of the things AI can do is actually AI is doing now is, can AI go through these photos in the telescope itself? Can we put an AI there, or basically a machine there, which go through these pictures? And if the pictures are for sure not useful, they are not going to be sent. So the pictures are not very sure or useful, they are going to be sent, right? So those who are, if the AI figures out, okay, these are useless, these are like just standard pictures, no point of sending them, then they're not going to be sent. So by doing that, we reduce two things. One, the human effort on Earth in terms of how much we spend, how much time we spend, and so on. And obviously, the most other important one is the data that is transferred between the telescope and Earth stations. Because now the data is going to be reduced, and therefore it can be sent. One, it can be sent faster. The other one, it can be sent cheaper. Okay, so there's a question not related to space. The question is it possible to save human memory to a mind drive? Yeah, actually people are working on such projects, but memory itself is not what we need, right? So we are here talking about artificial intelligence. It's not just memory. But there are projects that are working on such things. Yes, interesting question. If you have more questions, please feel free to put them. Let me go into the next topic, which is the space navigation. So we went through a data analysis, space, I answered a question on that same topic. AI robotics, where robotics can be used in space exploration. We gave different example situations. Safety management of people, equipments. Particularly equipments are of very much interest for the reason I mentioned. Things like predictive maintenance is something that is a lot looked at these days. So predictive maintenance has a lot of applications. Can we figure out some machine is going to fail before they fail? That topic. Space navigation is what we are going to do next. So we already spoke about Falcon a bit. The machine like rockets like that are AI powered. So they have autopilot programs. Even as you know, even aeroplanes have autopilot programs that does most of the routine work of flying, and in this case, yeah, space exploration as well. And they decide that under these programs look at various aspects, various sensors, sensor information, sensors including cameras, to decide what to do and how to navigate and how to, like, which in the case of in the case of an aeroplane, because I mentioned that earlier, it also helps us how to fly. In addition to the rockets, one other place is things like the satellites, which are things like, for instance, SpaceX has their satellite, what do you call the satellites for, the satellite named Starlink. In fact, like the video we looked at earlier had an example launching of the satellite, Starlink satellite using Falcon 9. So here is the satellites are AI is going to be used in this for navigation, right? So I actually mentioned a little on this during robotics example, where you can use the collision avoidance and so on. So yeah, so space navigation, they are used for various actions. In this example, I'm talking about predictive, like prediction and identifying where there are debris and things like other satellites are there and so on. So they are used a lot. So space navigation. So the next one, in addition to space navigation, let's also talk a little on the planetary navigation. In fact, like there is a lot of overlap between these different topics, because they are like, these are not done individually, but I'm looking at the different perspectives of the same work depends on these topics. So planetary navigation, will look at some examples. Say, for instance, if you are talking about Mars exploration, NASA had 4 goals. One, to determine if life ever was there or arose in Mars. We believe there's no life right now, but was it there? That sort of anyway, shows life. And the characteristics of the climate characteristics of Mars, geology, and we are prepared to prepare human exploration of Mars. So these are the objectives or the goals NASA had. With that in mind, what sort of things AI can help the Mars exploration? Obviously, we sent Curiosity, which had an AI on board. And the algorithm is known as the autonomous exploration for gathering increased science. That is how it is named, AEGIS. And it is used to identify rocks and various other terrains of interest, and to take photos of those and collect data about those. All that are done using the Curiosity rover. And obviously, it's related to the Mars exploration. There are a lot of algorithms used only in. So here we are talking about the algorithm that the AI that is used in terms of exploration of Mars. And other rovers like Perseverance was sent to collect things. I think NASA is also running a project called AI for Mars, which does a lot of AI algorithms, including things like computer vision or machine vision. And a lot of research and publications done on these areas as well. And here, this one is supposed to go and collect samples from Mars. So that's on navigation of the planetary navigation. Earlier, you were talking about space navigation. And the last topic I have under this big AI for space exploration topic is communication and system control. So whether AI can be used for communicating, various types of communication, robotics, AI communication between other people, AI communication, and controlling systems. In fact, like few things were already mentioned. For instance, the example I gave earlier about the collision avoidance, there is also communication. Right? But then let's focus more on communication under this topic. So communication and system control, there is one example here, which is related to transmission or communication in that sense. Cognitive communications, NASA calls it. So AI-powered cognitive radios are used for enhancing the communication. Meaning, like like when you want to transmit radio signals between space and here, there are a lot of disturbance, lot of noise that is there. So and also various other disturbances, solar flare, various other disturbances that are coming in between and disturbing the communication. So usually what if there is no machines to identify these disturbances and to switch frequencies, for example. So let's say one frequency got interrupted, can we switch between other frequencies? All these are usually in the past, long time back, were done by human, and they are very difficult to do, and also they are not fast enough. We are not fast enough to do such switchings. But now they are done by using AI. So AI can switch between or do better noise management control, so which helps communication. So AI, there is NASA using AI on that, and obviously others do as well. So here is another one, NASA's Space Communication and Navigation Test Bed, also known as SCAN. That is there in the IS International Space Station. What it does is it does this sort of what is known as like communication related support. Like I said, noise identification, cancelling, sending filtered data or less noise data to us back to Earth and so on. So these are done using AI algorithms. So just all what we have discussed up now are under topic 3, AI for space exploration. And before I go into the next topic, which is I wanted to just highlight, okay, all of these are done by either German Space Agency, NASA, and SpaceX. Looks like they all are far away from what we can do here in Sri Lanka. So I just wanted to highlight a few projects, AI-related projects, not specifically space-related, but the applications of the AI-related projects we did and the applications we discussed in the space exploration. You will see a lot of similarities. So I want to highlight a few projects that we are doing here in Sri Lanka at the University of Peradeniya in my lab related to AI. That is the next topic I want to cover. Before that, if you have any questions or comments you want to share, feel free to do so. I'll give a few seconds to see whether anyone wants to share something. Okay, all silent. Thank you for being so a silent audience. And let me go to the next topic then, which is something that is very close to my heart, the projects that we are doing in my lab and around. In fact, like some of these projects are not just done in a single lab, they are done across multiple disciplines, not just engineering, but also other disciplines which are applications. So we at Peradeniya has this lab we started about now 15 years ago called SCAL, Embedded Systems and Computer Architecture Lab, that does a lot of IoT, AI related work in collaboration with a lot of other researchers from various other places, including the other disciplines at Peradeniya, other universities around the globe. But these works are done now, almost all of them are done, like a lot of them are done with researchers here locally getting involved. One of the projects, because we mentioned about robotics earlier, one of the projects that we do is swarm robotics. It's called PeraSwarm, which is robots that are built ground up in Sri Lanka at Peradeniya with AI algorithms doing autonomous navigation And these robots are behaving like swarm, as you might know. I hope you know what swarm means. Like ants and birds and so on, how they all fly. So using similar ideas, they work. And we have built a large number of different platforms around them to do, for example, you can upload AI algorithm to these robots remotely. So you can even upload algorithms to these robots from the web, from wherever in the world, and you can observe how they behave. We also have built these robots that we have what is known as what do you call this, virtual reality, or VR. So there are some physical robots that you can see. These pictures that you are seeing are physical robots. At the same time, there are also robots that are not real. So this is coming through a picture. And so in the virtual world, there are some robots. So there are virtual world robots, there are physical world robots. They can interact with each other. Things like how the virtual reality works, but here the robots, virtual and real world robots, and they can interact with each other, how these algorithms can interact with each other and so on. Some interesting work we are doing in this area, and the details you can find from this website or the QR code. And we are happy to have others involved, so if you are interested. So there are other projects, again, related to virtual reality, augmented reality. Here's a game that was developed, known as AR Compact, where we also have the AI involved in this environment. With agriculture, we are working on a project, and here are some research publications on it related to smart greenhouse automation, how we can use robots to AI to automate the greenhouse, basically. The automation involved Internet of Things, and then we collect data from that, and the data is fed into an AI algorithm, or like machine learning algorithm, with that it decides and controls things. So there are research publications related to it, and also a lot of these are all built, and they are in the Agriculture Biotechnology Center at Peradeniya. And small other projects, things like Smart Glove, which again uses some AI. I believe such things. So this one is like for what you call sign language. And similar to the robots I was talking about, the swan robots, here is a remote keyboard or piano tutoring. Can learn piano remotely, right? So without a tutor being there. Or can AI come in and replace a tutor or a teacher who teaches piano? There are projects of that nature done. And CopMate is another project where we use AI to detect those who break road rules. So with computer vision. That's another project. More on this is another topic that is very popular among AI research these days. Now that with generative AI and AI decision making, can AI understand human emotion? Right? So can machines understand human emotion? This is a project we started sometimes back, 2018 actually. Here is a publication from those days, but we keep improving. The idea is, can we use sensors to understand human emotion? In fact, this project we started as like a fun project for building games. So let's say we have a first-person shooter game, and can we make the game's difficulty depends on the person who is playing and the person's mood or the emotion. Let's say somebody is feeling energetic, we'll make the game more energetic, more like challenging. If somebody is feeling sad, let's make the game easier, less challenging, or things like that. So can we bring in such ideas into the game using emotion recognition. We also worked on other projects like can we recognize emotions of the listener to play music. Different type of music depends on the emotion. So emotion recognition has a lot of applications. So in fact, like now that machines, if they can become like very closer to human intelligence, can they understanding emotion useful for people or useful for those AI machines so that they can help human better. So emotion recognition is an interesting area, and we are doing a lot of research and applications using emotion sensors, basically human vitals, to do that. We work on other projects. Here is one a collaboration work with Peradeniya and a university in Australia, where we worked on precision agriculture. Can robots and the programs run like unmanned aerial vehicles, and the programs running on them identify weeds in big farm area and so on. So you can see similarities between this and, for example, the type of algorithm that runs on Mars rover. Right? So because they are supposed to work on their own autonomous and go and identify things, and like in this example, they identify weeds and spray some pesticides and so on. So the type of algorithms are closer, and this again was published in a good journal some times back. And there are other projects, things like the health watch is one where we have watches that are wearable for patients, and they are all connected. Let's say in a hospital where you have beds and common dashboard where all these can be connected and used. It's a bit older project, but yeah, it's still there. And some other projects where we are working with researchers outside the country. Here is one. This is a healthcare application where we are building wearable. So here it's a t-shirt, a shirt that can, or here it's a t-shirt that can identify our sleeping patterns, identify those who are getting sick, early prevention, early detection, and so on. Heart problems and various other aspects. In fact, like sleep apnea, there's a disease, and can these clothes or wearables help? So how they are connected to AI is obviously the data that is collected from the sensors are used by AI algorithms for prediction, for identification, and various other aspects. Another topic we work on is again with another research institution who are doing genomics research. For example, identifying, let's say in the recent past example, COVID using blood samples, for instance. So such projects usually are done by using large computers. So this particular project is on mobile genomics. Actually, a couple of projects that are there. One uses deep neural network, other one uses some standard other algorithms. So these projects, they do use AI for analyzing the data that are collected, and then predicting or coming up with solutions. So here it's genomics data, so the data related to like DNA, RNA type data and gene data. So that's the type of projects also we do, where we use AI a lot. So those are the different type of projects that are happening here just around the corner. And it's possible for us to work on such projects even here, obviously with collaboration with a lot of others, other researchers in this area. Unfortunately, we haven't directly deal with projects of space exploration, but like I said, there are a lot of similarities with other projects. So in fact, like there are a few projects where we did deal with space exploration, but with the AI parts as well, but they are kind of done by other institutions here. Let me move on to the topic one before last. So we are going to close it very soon. One is the ethical concerns. I mentioned about it because now that AI, particularly the generative AI, can make decisions for people, can they, what are the ethical considerations we had to be concerned about, and also the regulations that has to be put in place so that they can be done properly, because the machines are going to take decisions. So ethical concerns, here are a few listed. One, autonomous decision making. It is a concern because if the decision is wrong, then it could mean in the space exploration category, it could mean the crew, the life of the crew, or the mission itself, or the equipment. They are very expensive, and therefore wrong decisions can cost a lot. Yes, it is a concern. AI can make wrong decisions. And however, it's also a concern, these decisions can lead to other problems. So particularly things like who own these decisions is another problem, right? So when a decision is made, normally when decisions are made, someone owns those decisions, people, right? So they can be put on to trial, they can be put on to negligence, different aspects. Now that the AI making decisions, when they are wrong, who are going to own those decisions? So those are things that are ethically concerning, but we had to come up with solutions. The next one is resource allocation and ownership. When you have these data decided, let's say, for example, in the previous situation, if the data are collected by AI, the AI decide this data is useful and this is not, then who is owning the data, and who owns the resources that are extracted from there? And can this and also in related to data, as you might already know, there are, so when it comes to data, there are going to be only few large corporates who are going to be owning human related data and data that are generated by this communication, and whether it is okay for only few entities to own them, and when we don't have access to them, like general humanity don't have access to them, what are the implications of those? Those are problems. And one other problem related to AI is transparency and explainability. Usually when human make decisions, we explain why we make such decisions, and we have some reasonings behind it. With AI, it is possible for us to ask AI to explain. So there is a complete field called explainable AI. So what the researchers are doing is they are building AI algorithms that can explain why they make such decisions. However, the concern that those who are concerned about the ethical aspects are worried about is whether the explanation the AI gives are comprehensible by human. Because when you have large amount of data, and AI make decisions based on large amount of data quickly by looking parallelly on a lot of different things, which we cannot normally comprehend. Now, if AI come and tells you, okay, this is why I made this decision by looking at this million different points, these points are this, these points are this, and therefore I decided this, whether it's possible for us as human to understand what it means, because it's too large for us to comprehend. So those are, so transparency meaning we don't, what if AI don't tell us, or if AI are not giving us the reasons for making decisions. And the other one is explainability, whether AI can explain is one problem. And even if AI explains, whether such explanations are comprehensible for him. So those are ethical concerns where we are looking for answers. And the next topic or next concern is privacy and data security. So when you put in this information to the AI model, particularly things that are mission critical, can these models be used by others? Can they be cracked? Can they be figured out what's going on? And also the data that is put in there, how safe they are. So even in the other context, things like what we are doing here, let's say we are building something here, not space related, but still data that are put onto AI systems, can they be securely or protected, and the privacy of the data from where they are generated can be protected. Those are of concerns. The last one under ethical concerns is interstellar stellar communications. Right, so when you are sending data beyond our into the solar system or out into the space, we might have to worry about what are we going to send. Usually what the communication we send are sent by human, but now if AI can make decisions, can send communication on its own, what do we have to worry about? So these are concerned. Actually, the topic related to space communication, if I'm right, there are guidelines. Even NASA was working. I think I put some slides. Yeah, okay. So regulations. In fact, like there was some recent development on these. There is a framework developed by NASA, framework for the ethical use of AI. You can go and search for it, and it's a document that is out there. And also NASA and SpaceX together, they come to an agreement related to how these sort of communication and various other aspects of space are done. So, but with generative AI, these things has to be again updated. The AI making decisions, and therefore things has to be updated and improved. I see a lot of such work happening. There is a group with a lot of scientists from various places. The group is run by NASA. I can't exactly remember the name of the group right now. They are working on those. So to concluding remarks, to finish this discussion, I already have highlighted various aspects where AI can be used in data analysis, mission planning, mission operation, using like the telescopes, space telescopes, knowledge discovery, how decisions can be made again on which data to be sent, which one to be transmitted by efficiently, quicker, saving money and saving human time and effort. All that we discussed. And things like when it happened, when you want to do navigation, space navigation, the challenges that are there, how robots can come and help there. And even things like this Falcon 9, what happens when it comes back, how you decide where to land, autonomous landing, both coming back to space and also on planetary explorations or navigation. We have seen a lot of examples on how AI can be used there. We also looked at communication, how AI can be used there for noise reduction, how the right channels, things like frequencies, which channel to send data can be decided by using AI algorithms. So we looked at a lot of examples. And also there are a lot of new things that are happening. There's a very recent article, I think it's just very recent, within the last month or so, China talking about coming up with a way to build a robot that can convert or generate oxygen from water. There's this discussion about it. Okay, so that's the news article about it. It's in Nature. And so such things keep coming, and they are done by various new algorithms and ideas that are generated, obviously with a lot of other research in other areas involved, including material science and so on. Right, so that's basically what I have. And any questions? Actually, there were some questions already there, and that was pre-collected. And I gave answers to most of the questions that was there in my talk. I integrated them because I collected the questions earlier. Yeah, I'm happy to answer if you have more.
Thank you, Professor Regal, for that enlightening presentation today. Now we open the floor to questions from our audience. So please feel free to type your questions in the chat or raise your hand to speak directly.
Thank you. I think a couple of questions that was not answered earlier. Like while you are preparing a question, please type the questions in.
So your questions are essential to make this session valuable. Don't be hesitate to raise your hand or submit questions through the online platform.
So there are a couple of questions related to extraterrestrial intelligence. I haven't covered it specifically in the presentation, but yeah, so there is again a lot of data coming in, and AI is used in a lot of those places as well. Even recently, as like last year, there were a lot of work that were public in that domain. Things like the Green Bank telescope that is used collects a large amount of data. If I'm right, some 100 plus terabyte per day or something like that. And then AI is used to analyze through those data. This is related to the extraterrestrial intelligence. That was a question that I couldn't answer in the regular presentation. If you have more questions, please feel free to bring them up. All silent? Oh, that's fun.
So there are many some questions before created. How does AI assist with life support in space habits?
Life support. So life support, in fact, like life support everywhere, even here. Now the AI is coming into the picture. So how it helps is obviously by looking at the vitals, the prediction of how it goes. Say, for instance, by looking at various heart rate, the pulse, and various aspects. That's happening everywhere, even in space. And the space suit, for instance, has all these things incorporated. And who is observing these sensors is not people. They are obviously observed by machines or AI algorithms, and they are the one who are like alerting, right? So that's how the support works. And then obviously there are also recently I saw articles on how using this information, how the AI again algorithms can control things like how much oxygen to use, how to say even if there are problems with the oxygen leak, how you can preserve some various other aspects. So yeah, there's a lot of AI used in such aspects as well. Can AI affected by attacked by a virus? Yes. So it's an algorithm. So it's a program. So therefore, like any other program, the virus is also a program. So yes, it can be AI programs can be infected by this. But the point is again so virus detectors, for instance, they are again programs. So it's possible for these AI algorithms to develop better programs to avoid those. So it can, yeah, you can imagine a war happening between the two types of programs. That's possible, that's practical.
There is another question. Is it possible to use AI to control elephant-human conflict in Sri Lanka? For example, fixing sensors.
Yeah. In fact, this is done already. Actually, this is, it's been done only at several research levels, but we haven't seen anything yet properly implemented. But yes, so AI is used in human-elephant conflict by using different type of sensors, and also like motion type sensors, and also cameras. They are also calling cameras as sensors. Vision related, so you are basically not like computer vision or machine vision. They are used to particularly identify elephant or elephant behavior, where they are, how they interact or how they go around and such ideas, and therefore use those information to alarm or also to support human. So that research level, they are a lot done. But and if I'm right, somewhere in Thailand, also Indonesia, there are some practical implementation of those as well. Here we have not yet managed to get them implemented.
And so there is another one. What are the challenges and opportunities exist in using machine learning during space mission?
I think I already, all what I discussed are opportunities. Challenges, the things that I brought in during the ethical considerations are challenges. Say, for instance, so opportunities are obvious, right? So all what I listed earlier are opportunities. We can do a lot and also a lot more. If I want to give a short answer, actually I gave this. This is how I started the talk as well. But just to reiterate, space as of now, it's a lot difficult to keep people there because of the environment, the harsh way of environment, the oxygen, various other aspects, water, food, all that, right? So it's not easy to keep people, a lot of people there in space. But we want our presence and we want to do at least be there to figure out how to keep people there. So AI or this intelligence, which is maybe not as good as human, but some intelligence, keeping those intelligence there is a way of starting. So that is an overall answer, like a big answer why AI can help space exploration, because it replaces human or it augment human or complement human. So we can put those fellows there. When I say fellows, I'm not talking about like robots alone, but anything that has some intelligence. It can be just some a small device that stays there and understand the environment, observe what's going on there, make some decisions, tell us what's happening, and so on. So that's the opportunity. So it's a really big opportunity in that sense. We don't have to put people there to do everything. Challenges, yes, whether they are good, whether they can work properly, whether we can rely on because there's no responsibility or there's no ownership. So when you put a machine there and the machine make decisions, who own that decision? So that is a larger challenge, not just in space, everywhere. So that is the challenging side overall. But the smaller like sub challenges I discussed earlier, like during the ethical discussion, data security, and various other aspects of those are also challenges. But the main opportunity is that we can send these things to be in places where they are difficult to keep human, but at the same time, how much we can rely on them because there's no one to take the ownership of the decisions that are made. So those are the opportunities and challenges at a high level.
Our next one is, how might AI contribute to solving the mystery of dark matter and dark energy?
Okay, so there are some questions about dark matter. And so again, the data that are collected, in fact, I had even now that I think there is some new project that is happening, which is going to be a satellite that I think a space telescope that is going to be launched. It's made again some NASA sub-agent who is making it. I can't exactly remember the name of the telescope. It is to analyze dark energy and dark matter. So it's called some Grace Roman. Yeah, Nancy Grace. Yeah, Nancy Grace Roman. So there's a satellite that a telescope that is made by NASA. So what they are going to do, they are going to launch it in in 3 or 4 years time. It's being prepared now. So that is going to go and do dark matter or dark energy related analysis. So they are putting in a lot of lot of AI in there. So the idea is they're going to, in fact, like companies like NVIDIA, I think, is working with them on putting AI, some computer there, like a very high performance small computer that can work in that environment and analyze the data there itself without bringing them here. So yeah, so such things are happening related to dark matter.
Next one is,
Yeah.
what role can AI play in improving the efficiency and accuracy of space debris tracking and mitigation strategies?
Mitigation, okay, tracking. So again, so how AI can come in is the things that I already said earlier. If these things are observed by telescopes, then the decision making can be done then and there itself without bringing them here, because these are like well-known objects and pattern shapes, various aspects, right? So it's not that difficult actually. So that way we can use AI there for decision making on those. Even decision making prediction is another area. So if there are any upcoming danger related to those, they can be predicted well in advance because AI algorithms are reasonably good at making future prediction based on a lot of data, right? So which takes a lot of effort for human to do, but AI can do prediction by looking at various type of data, including the planetary movements of various aspects. And so it can make decision by looking at a lot of different data. That's the point. So therefore, it's possible for using AI to predict what's going on there, and using those predictions, we can make decisions. We can even if they are related to satellites or our other objects that we are flying or we are letting in the space, we can make their navigation control using those decisions. So that's useful.
So someone has asked in the chat box this question: can AI express human emotion on par with humans?
Can AI express human emotions? Okay, so that's an interesting question. I also mentioned something about emotion in my the work that we are doing. So whether AI express emotion, I think the answer is yes. The problem is whether AI feels emotion. The answer is no, right? So for us, this is the point, right? So for human communication, emotion is very important, at most important. So that there is a concern whether AI, so let's say AI being a machine or robot or anything else, just an application, can it communicate with people, human, as best as human communication, right? So that is where AI emotion is important. So the answer to that is what the researchers think is AI doesn't have to really feel emotion, but if AI can express emotion or AI can understand in the sense things like whether AI can understand what human emotion is. Like right now, if I'm talking in front of this camera, if an AI running on it, they are know what I feel, right? So or identify what I feel. It doesn't have to feel what I feel. Just identify what I feel is good enough. So that why it's good enough is because it can then respond to it in a way how it's supposed to be responding, a human supposed to be responding, or in even a better way, right? So, like the problems with human emotion is also we have a lot of negatives. All the fights, all the negative things that are happening also related to emotion. But also obviously there are a lot of good things. So AI, whether it can express emotion, it can't feel, but it can express. It can express in the sense it can talk to you nicely, right? So, but does it know that it's nice? Does it know, like, does it feel it's nice? No, doesn't have to be, right? So it can tell you nice things, nice stories. It can make you feel better. All that it can do. So yeah, so that way it can express, but it doesn't feel.
Unfortunately, due to time constraints, we will need to bring this session to a close. If there are any remaining questions or points to discuss, please feel free to share them briefly, and we'll do our best to address them.
Just Ravindra, can you let me share the screen? I have a closing slide to just show. I'll just show that, and then you can finish. Right, thank you. So I just have my the profile page, and if you have any questions, you feel free to reach out to me. That's my email address, and I'm on LinkedIn. That's my LinkedIn profile. Right. So in fact, like, I want to finish the session before handing over to Ravindra is just to highlight what Jensen Hong, the CEO of NVIDIA. NVIDIA is, if you are not familiar, is a really like large company who is supporting a lot of AI development now, because AI need a lot of computing, and NVIDIA is a company who support computing resources. In fact, last year, the CEO of NVIDIA won the Best CEO award for all the AI work that they are doing. So he says, like, 20 years ago, all of this AI was just a fiction, but sometimes ago it's like a dream that we can do, but now we are living it. I think we are done a lot as human being in this aspect. Yes, there are a lot of challenges, but more than challenges, there are a lot of opportunities. And I hope, quoting the NVIDIA CEO, I'll also welcome you all to explore further and enjoy exploring the space as you all are doing now and in the future. And reach out to me if you feel like you want to talk to me, get some thing working together and so on. So my profile and details are here. Thank you very much for having me. Ravindra, now over to you.
Thank you, sir. We want to express our deep gratitude to Professor Roshan Regal for his invaluable contribution to our today's session. His presence added immense value, and we are truly appreciative of the insightful and knowledgeable perspectives he shared with us on the fascinating intersection of AI and space technology. So thank you, Professor Regal, for making our session more engaging and more enlightening.
Thank you very much.